everyone, my name is Mariela Koholin, and I am presenting my thesis titled Best Practices in DNA Analysis, Assessing the Current DNA Profiling Methods Used to Identify Individuals in Mass Graves and How Strengthened International Standards Can Improve Reliability. So, why should you care about this topic? Around the world, there are many mass graves containing unidentified victims of mass violence. There are several recent instances of mass graves resulting from genocide, such as the Rwandan genocide, and other atrocities like these are still being committed even today. Throughout the 20th century, in Latin America and Spain, there were several types of these events. In 1976, the Argentine military staged a coup against the president, Isabel Perón, who was in power at the time. Anyone who expressed dissent against this new leadership or supported socialism was marked as a target of this new regime. These people disappeared, being kidnapped, tortured, or possibly killed. Around 10,000 of these disappeared people have been documented. However, the Argentine human rights movement claims that over 30,000 people who disappeared were murdered. As of 2015, only 900 bodies of these estimated 30,000 disappeared in Argentina have been recovered, and only 500 of these have been identified. Clearly, there is currently a discrepancy between the number of people who were killed and the number of people who have been identified as victims of this regime. Exhumations are evidence of atrocities of the past, bringing them to light and calling perpetrators to be held accountable. Through the recovery and identification of individuals, community members are reunited with their loved ones, providing closure and helping to heal this community at large. Today, we have the technology to identify these victims through DNA analysis. DNA analysis is now commonly used to aid criminal investigations, establish parentage, and to identify victims of disasters and massacres. I have broken down DNA typing, a complicated process, into 4 general steps: sample collection, DNA extraction, DNA fragmentation, and DNA fingerprint analysis. Once a sample is collected, the DNA first must be extracted to become isolated from the rest of the sample. Then, the DNA is cut up into pieces using restriction enzymes. These pieces are separated from each other based on size during electrophoresis, and they are marked with probes so each fragment can be visualized, creating a DNA fingerprint. This fingerprint can then be compared to other samples to determine whether an unknown sample matches a known one, such as what occurs in kinship analysis. Now, I've just described a process we already have established. So if we have these methods and procedures already, what's the problem? There are some challenges that come with DNA analysis. The accuracy of these analyses is extremely important to prevent further trauma to the community in the form of misidentifications. Mishandling DNA samples when collecting them can be detrimental to analysis. In Argentina, the first exhumations were performed in the 1980s without proper forensic techniques. The most glaring example of this occurred during the first exhumation of the San Vincent Cemetery in Cordoba. The exhumation was performed using a power shovel, which increased the likelihood that the remains could have been damaged. The skeletal remains were then placed into bags separate from their skulls, commingling the remains. This excavation destroyed part of the mass grave, and 33 bags with remains were missing when the site was re-examined in 2003. If evidence of these atrocities is compromised, the likelihood of positive identification is reduced. There are several types of DNA, and these types of DNA have different levels of reliability. When extracting DNA from remains, nuclear DNA is the most valuable because it can be associated with a high degree of reliability. False positive identifications using nuclear DNA are rare. However, if nuclear DNA is not possible, such as in the case of extreme DNA degradation, other typing methods can be used. These typing methods include mitochondrial DNA typing, or mtDNA, Y-chromosomal STR analysis, and nuclear DNA single nucleotide polymorphism SNP analysis. mtDNA and Y-chromosomal analysis cannot provide absolute identification, but could provide other information about the remains, such as a common profile of all people with a common female ancestor or identification of male remains, but are not definitive enough alone to develop a profile of a specific person. SNP analysis can only provide a profile in highly specific scenarios. Errors with misidentification are more likely to occur in these situations when there are limited amounts of nuclear DNA. Now, there are many guidelines and recommendations that exist for the identification of human remains, but there is still no internationally accepted universal standard for this process. To get a better understanding of which procedures were most important in the identification process, I examined several guidelines for DNA profiling and kinship analysis, including those put out by public, private, national, and international organizations. By reviewing these guidelines, I identified several key procedures, but also found several inconsistencies as to what content was included in the guidelines. All of these guidelines had placed heavy emphasis on collection, storage, and analysis. The level of detail that went into each of these sections varied among guidelines, showing a need for a single, detailed set of standards. Specifically, detailed procedures regarding carefully collecting and storing samples should be written. DNA can be damaged during collection, and collection is just as important as analysis, because if the samples are not handled correctly at this stage, then nothing can be done later to salvage the damage done. Here, I have included just a few suggestions which I think should be included in universal standards. While collecting this material, sterile techniques should always be used, and all biological samples should be packaged separately in paper. The collection of reference DNA samples is also important, especially when trying to identify individuals in mass graves. These reference samples can be taken from family members or from items that contain DNA from the deceased. When storing and transporting biological samples, the DNA can be stored within the sample or as extracted DNA. Biological evidence is best preserved and stored dry and cold to reduce the rate of bacterial growth and DNA degradation. Samples should be packaged and handled carefully, specifically stored at 4 degrees Celsius or in the freezer at -degrees Celsius at all times. For longer-term storage, DNA can be stored at -70 degrees Celsius. During DNA typing, it is currently recommended that a minimum of 12 markers should be attempted on all samples for STR typing. Typically, STR typing is used for forensic DNA typing. STRs are short tandem repeats, which are sections of the DNA which do not code for proteins and repeat a variable number of times in the different individuals. The more sections or markers of STRs which match in a comparison of two unrelated people, the smaller the chances are that these samples came from two different people. The decision regarding which markers to be used should be made early on in the typing process, and all preceding laboratory tests should use the same number of markers. Targeting a greater number of markers than 12 allows for even more confidence in results, which is why 12 is only recommended as a minimum. The likelihood of two unrelated people having DNA samples which perfectly match at 13 STR locations is said to be 1 in 1 billion. Although there are current recommendations for the number of STR markers, it is not technically a requirement due to the possibility of partial profiles caused by severely degraded DNA. These are just some of the techniques that should be included in a set of universal standards to be upheld internationally. I elaborate further on these techniques in my thesis. After establishing a detailed set of guidelines containing all of these methods, they should be distributed internationally. Forensic scientists should be trained uniformly to follow these guidelines to ensure everyone is using the same techniques. These solutions come with their own set of challenges, though. These challenges lie outside the scope of my thesis, but they are worth identifying. These types of analyses can be expensive, especially with mass exhumations. This begins a debate about who would be responsible for the need of analyses. Family members, perpetrators, or governments are all possible options. It also is difficult to determine which organization would be best for publishing the guidelines. Would an international body like the United Nations be best fit, or should a scientific organization be responsible? Standards can be published, but they will do nothing if they are not followed. How can scientists be held accountable, and how can we be sure that they are abiding by these procedures? Finally, what about special cases? Cases of forensic identification vary widely. It might not be possible to uphold every single standard in every single case, such as with a partial DNA profile. Should an analysis be considered invalid just because one standard isn't met? I don't have these answers, but these, along with ensuring human rights are always upheld, should always be considered for analyses. The scientific community has made immense progress since the 1980s, when the first exhumations began in Argentina. In 2003, bone samples from individuals originally exhumed from San Vincent's mass grave in 1984, without proper technique, were reanalyzed by the EAAF, El Equipo Argentino de Antropología Forense. the Argentine forensic anthropology team. These samples were compared to blood samples from possible relatives using kinship analysis. As a result, 4 disappeared persons were identified in 2003, and 6 additional identifications were made in 2005. Through the work of the EAAF, the remains of over 200 people were exhumed and examined, and samples were taken from 400 relatives for kinship analysis. In 2004, an investigation by Catelli et al. Re-examined a mass grave using STR and mtDNA typing. Through this analysis, not only did the scientists on the team discover that 4 of the skeletons that had been previously assembled had been assembled incorrectly, but they were also able to identify 4 of the skeletons by matching their DNA profile to a reference blood sample from relatives. This was all made possible by improvements upon DNA analysis techniques, and with universal standards, there might be an even greater chance to increase confidence in results in the future. Alright, well, thank you for watching. If you have any questions, feel free to contact me at my email, mcaholen@umass.edu. It's listed right there. I'm also going to include some of my citations if you want more information. There's some of the various guidebooks and case studies I reviewed, as well as some of the articles about the importance of universal standards. Finally, I'd like to thank everyone who has supported me and helped me get to this point. My advisor, Laura Reed, my peer advisors, my family, my friends, everyone who's watched the video and made it this far, thank you. And then here are those citations, and thank you again, everyone.